Hi, good morning everyone. So let me discuss some more examples based on bounded sequence, monotonic sequence and convergent sequence. Okay, altogether one example. So example is show that the sequence Sn defined by S1 is equal to root phi and Sn plus 1 is equal to root of phi Sn converges to phi. Okay, so we prove this example by mathematical induction. Okay, so using mathematical induction, we can prove this example. Okay, solution for this, given what is given here, S1 is given and Sn plus 1 is given. So I am writing that S1 is equal to root of phi and Sn plus 1 is equal to root of phi Sn. So what I am doing here to prove by mathematical induction, first we have to check the result is true for n is equal to 1 or not. Okay, after that assume that the result is true for n is means k is equal to n, and the result is we have to prove the result is true for k is equal to n plus 1. So I am taking k is equal to 1. Okay, so therefore here n is equal to 1. If I put n is equal to 1, it will become S2, 1 plus 1. So root of phi S1. So S2 is equal to root of phi S1. Okay, so this is equal to S1 value is what? Root phi. So this is equal to root of phi root phi. So this is greater than root phi. So because the value of root phi is greater than root of phi. So root phi is what? S1. So that implies that S2 is greater than S1. Okay, so suppose Sn is greater than Sn minus 1. Okay, so I am multiplying your above equation, this equation, by phi. So then this implies that phi Sn is greater than phi Sn minus 1. So this implies that if I take root both sides, then it will become root of phi Sn is greater than root of phi Sn minus 1. So already given data is Sn plus 1 is root of phi Sn. Okay, and this is if I take this as Sn, then it will become, so in this equation, which equation means your Sn plus 1 is root of phi Sn. Okay, so if I put n is equal to n minus 1, then it will become n minus 1 plus 1. This is Sn. So here becomes phi of Sn minus 1. Phi into Sn minus 1. So here your result becomes phi, this one is root of phi Sn is Sn plus 1 and this one is Sn. Therefore by mathematical induction the result is holds good. Therefore Sn plus 1 is greater than Sn for all n. Therefore now we can say Sn is monotonically increasing sequence. Monotonically increasing sequence, because this is satisfying the definition of monotonically increasing sequence. Okay, so therefore sequence Sn is monotonically increasing. Now again I am taking S1 is equal to root phi. Obviously root phi is less than phi. Okay, suppose if I take Sn is less than phi, Sn is less than phi, then if I multiply this term by phi, then it will become phi Sn is less than phi into phi. Later I take root on both sides. Root on both sides. So root of phi Sn is less than root of 25. Root of 25. So this implies that this is Sn plus 1, because this is a given data. So I am replacing the value of root phi Sn by Sn plus 1, and root of 25 you know that phi. So therefore by mathematical induction Sn is also less than phi for all n. So therefore sequence Sn is bounded above. Sequence Sn is bounded above. So sequence Sn is monotonically increasing and bounded above, therefore it is convergent. So here I am taking limit n tends to infinity, Sn is equal to L. limit n tends to infinity, Sn is equal to L, and limit n tends to infinity, Sn plus 1 is equal to L. Sn plus 1 is equal to L. So therefore I am taking your Sn plus 1 as root of phi Sn. If I square both sides, then it will become Sn plus 1 square is equal to phi Sn. Okay, so you know that Sn plus 1. Later if I take limit on both sides, so this follows limit n tends to infinity, Sn plus 1 square is equal to limit n tends to infinity 5 times Sn. So you know that limit n tends to infinity, Sn plus 1 is L, and limit n tends to infinity, Sn is equal to L. Replace the value of both two, then it will become L square plus phi L. So if you take this will become L square minus phi L is equal to 0. L common, then it will becomes L into L minus phi is equal to 0. That implies that L is equal to 0 or L is equal to phi. But L is not equal to 0 because the sequence is monotonically increasing. So therefore we neglect the value, that is L is not equal to 0. Hence the sequence Sn converges to what? This L is equal to phi. Hence the sequence Sn converges to phi. Based on that, there are several examples. You try to solve those examples and try to understand those examples, because here we are playing with mathematical induction. These examples we are proving by mathematical inductions. So you try to know what is mathematical induction, okay, how it follows. So use that mathematical induction concept to solve these examples. So next example is show that the sequence Sn where a1 is equal to root 6 and an plus 1 is equal to 6 plus an converges to 3. In the similar manner, so now we have solved one example. In the same way, we are going to solve this example also. Here, what is given data? Let a1 is equal to root 6 and an plus 1 is equal to root of 6 plus an. So therefore, if I put n is equal to 1, it will become a2. N is equal to a2 root of 6 plus a1. So you know that a1 is root 6. So it will become root of 6 plus root 6. So this is obviously greater than root 6 is equal to 1. That is a1. Root 6 is a1. So therefore your a2 is greater than a1. Suppose if I assume an is greater than an minus 1, then if I add both sides by 6, then it will becomes 6 plus an is greater than 6 plus an minus 1. So if I take root both sides, then this equation follows root of 6 plus an is greater than root of 6 plus an minus 1. So this implies that this is an plus 1. So this is an, because already an plus 1 is given. In that, if this is already known result. So in that result, if I take n is equal to n minus 1, this is an plus 1 reduces to if you substitute here n is equal to n minus 1, then it will reduces to n minus 1 plus 1, that is an is equal to root of 6 plus an minus 1. Okay, so then we can say an plus 1 is an plus 1 is greater than an. Therefore by mathematical induction we can say an plus 1 is greater than an for all n. Therefore it is satisfying the definition of your monotonically increasing sequence. Therefore sequence an is monotonically increasing. Now I am taking a1 is equal to root 6, that is less than 6. Yes, suppose an is less than 6, then I am adding 6 both sides, then 6 plus an is less than 6 plus 6, taking square roots both sides, then it will become root of 6 plus an is less than root of 12. So root 12 is less than root of 36. Yes, so root 36 is what? 6. Root 36 is what? 6. Therefore this is what? Root of 6 plus an is an plus 1 and this is 6. An plus 1 is less than 6. So therefore by mathematical induction an plus 1 is also less than 6. An plus 1 is also less than 6. Therefore sequence an is bounded above. So here bounded above. Since an is monotonically increasing and bounded above, therefore it is convergent. So here I am taking let limit n tends to infinity n is equal to L and limit n tends to infinity n plus 1 is equal to L. So now n plus 1 is equal to root of 6 plus an. So squaring both sides, then this equation follows this, that is n plus 1 square is equal to 6 plus an. So taking limit on both sides, then it will become limit n tends to infinity an plus 1 square is equal to limit n tends to infinity 6 plus an. You know that this is the L. So this will becomes L square and this is 6 plus L. 6 plus L. So that implies that L square minus L minus 6 is equal to 0. So L square minus 3L plus 2L minus 6 is equal to 0 because minus 3 into 2 is minus 6. Okay, you add both sides, then we can minus L. So this is equal to 0. So taking common, this equation follows like this: L minus 3, and another term is L plus 2. L plus 2. Therefore, either your L is equal to minus 2 or L is equal to 3. By this, either your L is equal to minus 2 or L is equal to plus 3. But L is not equal to minus 2 because your sequence is monotonically increasing. Hence, the sequence an converges to 3. So, this is the solution for your given example. So based on that, there are several examples in textbooks. So you try to collect those examples. Okay. Otherwise, we'll send a list of examples as your assignment work. You try to solve it and return back to me. Thank you. Thank you one and all.